Good day guys, this is your tutor engineer. I'm back with the second video this week. Check out my first video that I did in order to be up to date with where we started off. So I'm going to do this question now. As I said, this is strictly for grade 11 and 12. Okay, that's the content. Okay, so I'm still going to do videos for grade 10. I think I've got a couple of videos that I've done for grade 10, grade 9 and grade 6. So but this particular question here is addressing grade particularly 11 and 12. So let's have a look at this. So when you're given a question like this to say prove this following identity, you have to take the most complicated side. It's normally the left hand side, right? So you have the left hand side, then you've got the right hand side. So the whole purpose is to make the left hand side proving that it's the same as the right hand side. So I'm going to take the most complicated side, which is the left hand side, right? So the first thing I have to do, right, the right hand side is just has sine theta over 2. So I'm going to change tan because I don't have tan on the right hand side, so I'm going to change it, right? So that's the first thing I'm going to do. I'm going to change tan to sin theta over cos theta. So that's how you change tan. And then at the bottom, I have a double angle, right? I'm going to change that to, I'm going to change this to sine 2 theta over cos 2 theta. So I must preserve the double angle as I make the changes, right? And then here the bracket, I'll change it to sin squared theta. So I think you can see, guys, what's going on here. Everything is changing from sin to sin and cos. I'm not going to multiply in. So when you're doing identities, guys, do not distribute into the bracket. Just leave the bracket as they are and just simplify from within, right? Now at the top there, sin theta and times sin theta over cos theta will give me sin squared theta over cos theta. So I'm not allowed to divide the sin theta over sin 2 theta because they are not the same. One is single angle, one is double angle. Okay, hope you understood that. Then at the bottom, right, let me just write the long line here. At the bottom, I'm not going to distribute still, right? I'm not going to distribute at the bottom. However, I can change the sin 2 theta to a double angle, right? Remember, sin 2 theta becomes 2 sin theta cos theta. So I'm going to do the same. So I'm going to take that, copy and paste here, sin theta cos theta. And then at the bottom I have cos 2 theta, right? So cos 2 theta can be various ratios or various definitions. One definition, for instance, is cos squared theta minus sin squared theta. I can change it to that. So if you don't like, you can choose either of these. One is more beneficial. It can get you to the answer quicker than the other. So let's just choose the first one, right? And see how it goes. So that's sin squared theta minus cos squared theta minus sin squared theta. So the bracket, remember I said I'm not going to distribute. You don't want to do that when you're doing or proving identities. So I'm going to take here the lowest common factor. Okay, I think I made a mistake here. I was supposed to have said cos squared theta there. So yeah, I've changed it. So the lowest common denominator will be cos squared theta. So there I'll have cos squared theta minus sin squared theta, right? When you put together that fraction. So guys, if you're not clear how to put together fractions, I'm gonna still do videos on that so that I can show you step by step. But the purpose of this lesson is not to address that. So I'm going to continue here. So now you realize that this bracket here is the same as that bracket over there. Let me just change color from here so that you can see, right? So this bracket is exactly the same as this bracket. So it means I can divide them out like that, right? So now you see the most complex step has become simplified just like that with one stroke. And then look at the bottom here. We have a cos squared theta, we have a cos theta. So that means this cos theta here will go and take one of the cos thetas here. So I'm just going to have cos theta, one cos theta at the bottom. So now the next step now will give me the top there. I still have sine squared theta over cos theta. At the bottom now, what do I have? I have 2 sine theta that's remaining, and the cos theta here, right? Cos theta, now it's just cos theta because one of the squared got cancelled out with the other cos. So now let's go back to black. The both cos thetas are at the bottom, so they can divide each other out just like that. And then this sine can divide one of the sines there, so that is just sine theta. So now this now will become sine theta on the numerator divided by 2, which is exactly as the right hand side. So that's the proof of the identity. So guys, please stay tuned. I'll be posting more videos like this video. I'll be posting more educational content of this sort. Like the video, subscribe, tell your friend to tell a friend to subscribe to this channel so that it can grow and help a lot of people. So thank you guys. See you on the next video. Cheers.